Well, good morning, everybody, and welcome to our webinar, Best Practices for Efficient Data Management in a Multi-System of Record, Multi-Application Digital World. My name is Jason Bloomberg. I'm president of Intelix, an industry analyst firm focused on digital transformation. And joining me today is Andrew Shosted, Senior Director, Solutions Engineering at GigaSpaces. So let's go ahead and dive in with some housekeeping. The session is being recorded. It will be made available on the GigaSpaces website shortly after the session, and I'm sure the fine folks at GigaSpaces will let you know where that is. We're welcoming questions during this webinar. It is a live webinar, so please use the Q&A module that you'll see at the bottom of your screen. It says Q&A. Go ahead and type in questions there. We'll try to address them either during this session, or if we have too many, then we'll follow up via email with answers to your questions. If you have any technical issues, though, use the chat function. That's the next button over, and there are people waiting to help you if you have some sort of technical problem. And lastly, the format of this webinar, or a virtual event, as we call them in 2022, is a fireside chat. So we only have a couple of slides. We're not going to go through a bunch of slides for you. It's really just some sort of placeholding slides. It'll be more of a discussion between myself and Andrew. So we should probably kick that off. The topic is really focusing on digital integration hubs, and that word digital is this key word here. And so it's great to sort of explain what we mean by digital transformation. I mean, it's a bit of a loaded term. It's a bit of an overused term, right? Digital really means that we use zeros and ones. And of course, we've been doing that for 50 years or more. So that's not really what we're talking about here. It's really more about leveraging technologies to better serve customers by aligning our organizations end to end with customer needs and preferences. So digital transformation is really changing a company who wants to transform itself, reorganize itself along these lines. So it's not just about leveraging technology. Technology is a supporting player. It's really about realigning the organization to focus on customer needs. And that realignment is both organizational as well as technological. And that's where the notion of a digital integration hub comes in. It's a technology that supports digital transformation. So I guess it's good to bring Andrew in on this. So Andrew, what does digital transformation mean to you? Can you bring some extra color to the discussion?
Yeah. Thanks, Jason, and great to be here. Everything is going digital these days, of course, right? So you mentioned, empowering the end user, that experience. And whoever that user is, right? It could be a customer, it could be an internal user, it could be a B2B application that you need to accelerate. As we shift towards our digital journeys, I look back to my individual experience and start thinking from a technologist standpoint. And so I took a step back. I asked my wife. I said, "What do you think digital initiatives are? What do you think the digital journey is?" She thought for a second and said, it's about not having to go to the bank, or it's about not having to go to the insurance company and kind of do it from home, right? And so what really that says to me is it's about the business use case. It's not about the technology. It's about what that user experience is. And so, there's lots of examples. I think we all can experience them of when this works great, when it doesn't work great. And so digital transformation to me is, how do you do it correctly, right? How do you do this right? I can really just bring in some anecdotal stuff, and I think that's maybe will resonate with folks. I had a personal experience. I had a car accident a little while back, and I was rushed to the emergency room. Everything's good, obviously. I'm here today. And as I was rushed in and had a bunch of scans and CT scans and such, I was waiting in the waiting room. I had my mobile phone on, and I'm getting these text messages. You have a new result. You have a new result. And I look, and I'm saying, oh, I'm all fine. I can see the result of my CT scans before they even came back to me, right? So kudos to whoever implemented that system. It was really great. It was more of an event-driven type of architecture. I can give you another example of when it goes wrong. When you get an alert on an application, it says, hey, your pharmacy order is ready to pick up, and you go to get it, and then lo and behold, they didn't even fill it. Right? They're saying you still need requirements from your doctor to get this filled up. So the point here is it's not just about, can you offer something in a digital format? It's about, can you do it the right way? Can you do it in a responsive way? Can you do it in an accurate way? And to me, that's where I think a lot of folks are struggling with.
Yeah, so we have, you mentioned a few different points, right? One is you mentioned the work from home scenario, right? People that don't want to have to go into the bank or the insurance company. And that's a key part of the story, especially now that we're, entering our post-COVID era, where work from home is really shaping up to be an established pattern, right? Much more so than it was before the pandemic. So digital transformation for many organizations during the pandemic ended up being a rapid response to the move to work from home. But even now that we're sort of used to that and we're moving forward, we still, organizations, enterprises still need to support a variety of different working scenarios, whether it's work from home, different kinds of office scenarios that aren't necessarily the same as the earlier ones. But you also talked about the messages in the hospital, and that brings together a variety of different things. One is it was very rapid, right? You got the results even before somebody came out to talk to you, and that speed is becoming an increasingly important part of the story. Of course, we all know that the stories about how e-commerce retailers realize that every fraction of a second of delay, they lose business, and that's true in e-commerce, but it's really true across the board, right? Fractions of a second of delay, of latency, of anything that interferes with that rapid experience for the end user, whether it's a customer or even an employee for an internal scenario, that's becoming increasingly part and part of the digital experience, and thus part of the technology challenge in order to meet that need. And then the third part of your story, which was actually the problem you expressed, where the pharmacy had a disconnect between what they sent you and what was going on in the store. That's also a challenge that centers on the omnichannel experience, primarily in retail. But you mentioned pharmacy, healthcare, right? There's other industries as well where the challenge is pulling together the different types of interactions that a company has with its customers or other users. So it could be coordinating the emails the store sends, the in-person experience, the sales representative in the store, and the technology that they have at hand. So if the sales rep has a tablet they're carrying around interacting with customers, as well as social media and other types of interactions. Those should all be coordinated in a single coordinated experience for that end user. That's the omnichannel experience. So one point is that this is part of that digital transformation challenge as organizations look to achieve this omnichannel experience. But another key point is that even though we think of omnichannel as being a retail and e-commerce scenario, it really cuts across many different industries, right? It's important in banking where you have mobile apps. It's important in insurance where you have claims processing and a variety of other capabilities, underwriting, and other things that insurance companies do. And it really cuts across many different industries. So we have this complex set of scenarios and complex set of technology challenges as well that all play into the story. But driving all of this, of course, is the role of data, right? The information that all of this technology moves around. So I think I'll hand it back to Andrew to talk a bit about data. What is the role that data play in digital transformation, especially in the context of some of these things that we've been talking about?
Yeah, fantastic. And I'll just echo some of your points, really, that I have a saying, milliseconds matter, right? Especially, you're talking about investments, positions, things like that, where, delays, whether it's a high latency system or, poor infrastructure, poor design, could mean millions and millions of dollars in some cases, or in some cases, it could be somebody's health, right? So as the role that data plays in here certainly is that, to provide that omni-channel experience, to provide that aggregated 360 view, we can talk a little bit about what that means too, of your customer experience. You need access to probably what has been a set of applications and systems of record and different applications that maybe aren't on a common platform, that most likely are not. And so you're starting to talk about merging different data models, different data technologies, different volumes of data. And then certainly as we look at how often data changes, it might be streams of data versus static data. So for example, let's look at retail or manufacturing, where you have perhaps static product information, but you're needing to combine that to deal with your supply chain challenges, right? You're looking at real-time streams of sales in stores, what are inventories and distribution centers. So all these different technologies were designed to suit a purpose, right? And the different data technologies that they've implemented probably work fantastic in that sort of micro view of what their task is, maybe inventory management at a distribution center, for example. But when you start looking at, how can you build a 360 view, operational dashboards, and trying to take the big picture look, especially these days, right? We see all these supply chain issues, for example, to keep on that example. How do you do that in a way where you can bring all these different data technologies together, see a common view, and actually accelerate the access to that data with a lower latency, so that you can actually offer to the consumers of your data better services, but you can also offer to the application builders a more streamlined process to actually deliver those services and develop those services and be more responsive and agile to the changing conditions that we see right now.
So there's really two parts of the challenge here that we're discussing. In this enterprise context, we have the end-to-end data challenge, which is really centered now on the integration problem, where we have the systems of record, whether they be databases or enterprise apps like ERP or mainframe data stores or whatever the back-end system of record happens to be. And we have to connect that to the end customer experience and everything in between, right? All of the middleware, all the intermediate systems, the network, all the security that needs to be in place to make all that resilient to the organization. All of that has to be working. But then you mentioned streaming data, right? So it all has to be working, and it all has to be working at speed with low latency, not only on a request by request basis, sort of a traditional request reply model, but also on a streaming basis. If you have the requirement for streaming data, which could be anything from a video feed to just massive quantities of enterprise information supporting some sort of real-time graphs or whatever the application happens to be. So this sort of it combines this these two challenges into this support by the back end for these kinds of services. So there's different challenges here, right? For systems of record, I mentioned a mainframe. Mainframes are they're still perking along. They still are the core transaction resource for banks, insurance companies, and other industries, airlines, and many others. And many of the things that we do as consumers interact with mainframes, right? The classic example is the checking your bank balance on your phone. That has to hit a mainframe to get your bank balance. But there's many different examples, and there's challenges supporting these digital priorities with a mainframe. Namely, it can be expensive, right? Mainframes charge by the transaction, and the more MIPS you use, right? The units of mainframe transactional capability, the more it costs the company. So that's one of the key challenges. But other challenges include regulatory challenges. There could be where your data are located, data sovereignty issues, or who can access it, who can access the data, or the policies in place about data access. So it could be everything from GDPR, U.S. state-based data requirements. So there's many very complex data regulatory requirements that are part of the story as well. And then there's also the API story, right? The interfaces to these various systems and how different parts of this technology landscape interact with each other, whether it's internal APIs for accessing your systems of record or third-party APIs for accessing third-party, say, cloud-based services. So there's a whole range of different things that have to work. And if any of them are too slow or broken, then you end up with a poor customer experience. So turn it back to Andrew. What are you seeing in terms of your interactions with customers or out in the marketplace in terms of recognizing these issues, facing these issues? Are you feeling pressure to accelerate applications? Are your customers feeling pressure to accelerate applications? And where are you finding the bottlenecks?
Yeah, you brought up some great points. So you use the term real time, and I think real time invokes this thought of not stale data. And so, people are looking to accelerate the aggregation of data in a way that it's event-driven. It's not sort of you have some nightly batch that gets pushed up, right? But the ability to say what's happening in real time, near real second, right? Near sub-second information at the application developer's fingertips. And it really invokes those challenges you mentioned, right? Of always on. Again, I look back to my own experience, knowing that certain systems of record will be down for maintenance or be tasked with some other processes. And so there are those periods of time where those backend systems of records are not available. And folks are saying, well, we can't just stop delivering those services to our customers at that time. We need to have the ability to have 24/7 in combination with low latency and real time. So the challenge really becomes one that's very complex to do it yourself. And that's really what I'm seeing, or what our customers come to us and ask about is sort of, how do I get to that point where I can deliver these real-time services with fresh, accurate data across multiple disparate systems of record? And it's a difficult challenge for sure.
Yeah, it's good that you emphasize that notion of real time, because the real time, it's a tricky notion because it means different things in different contexts, right? What real time, first of all, never means instantaneous, because we have the speed of light to deal with, right? There's only, if the bits have to get from point A to point B, it'll take a certain amount of time. So we're never really talking instantaneous. What we're often talking about is ultra low latency, right? That is, if we have to get bits from point A to point B, we don't want to have anything slowing them down slower than the speed of light, right? So we still have a fraction of a second, or some sort of millisecond to deal with. But even if we're pushing up against the speed of light, there are ways to improve our performance by moving the data sources around, right? And this is one of the challenges of a distributed environment, is that we don't necessarily have to go back to the mainframe for every request, right? There could be some sort of intermediary that can respond to certain requests, and those can be located closer to the end user, and that lowers latency. So part of the challenge is coming up with a distributed architecture that reflects this requirement for ultra low latency, in spite of the speed of light, right? In spite of some of these sort of fundamental physical limitations that we just simply can't overcome, right? But there are ways to get around them. Yeah, go ahead.
And I like your point about, not always having to go back to that system of record, especially, sort of repeating yourself by gathering the same static data multiple times. But the one thing I want to point out here is it's not just about a caching layer. In other words, okay, I recognize this request. I'm not going to make it again. I'm just going to pull from cache to service that request. You still have, in that type of model, you're still talking about a lot of, if you have changing data on a regular basis, you're talking about a lot of requests still to the backend system of record. And that becomes a challenge, is how can you switch that paradigm towards more of an event-driven approach where the data is already there and available to you, as opposed to having to make that request and or regulating how you're caching the information. And that's, again, one of the multiple challenges in delivering these highly responsive, low latency applications.
Yeah, absolutely. And ultra low latency latency is really only one part of the real-time story, right? If you think about different contexts, for example, if you're in a multiplayer game and it's a live action game, like a multiplayer shooting game, then low latency is important, but you also have this real-time interaction, right? So it's about responsiveness from the back end, but it's also about the interactions among the users. It doesn't always apply in an enterprise scenario, but there are increasingly situations where that real-time sort of real-time gaming kind of experience is important. But there are other situations where real-time is a part of the story as well, in terms of just being able to access information as needed on an ongoing basis. So you mentioned about requests to the back end, but the request reply, even though we always seem to fall into this pattern of thinking about distributed infrastructure as following a request reply pattern, how does the back end know what to do unless somebody makes a request of it? And then when it gets a request, somewhere there's some sort of query, right? Whether it's SQL or something in the back end, and then there's a response. And while that's still a very common pattern, it's not the only pattern, especially when we talk about streaming information, where you may have a live graph or the real-time gaming scenario or other situations. We're talking about the metaverse now, and the metaverse is not going to be a request reply architecture, right? It has to have a real-time streaming architecture, or you're not going to get that sort of metaverse type virtual reality experience. So as those sorts of technologies become more important to end users, consumers and business customers alike, then there's a whole new focus on real-time aspects that traditional technology, traditional middleware in particular, just was never designed for, right? So traditional middleware, you think about ESBs or other technologies, they're more likely to be based on a request reply infrastructure. ESBs in particular, enterprise service buses dating from the 2000s, weren't really designed for the cloud. That predates the cloud. So there's still a lot of middleware in enterprises that predates the cloud. It just doesn't work well in the cloud. Now, of course, there's a whole generation of cloud-based integration, the integration platform as a service, or iPaaS, where you have cloud-based integration. But in many cases, those are still request reply oriented, right? They still have this sort of notion that nothing's going to happen unless some user on the front end makes a request. Yeah. So as a result, they sort of shortchange the capabilities that enterprises are requiring now in terms of real-time, ultra-low latency behavior. So I know you put up this slide. So Andrew, you want to talk a bit to this slide while we have it up?
Yeah, I think you're hitting the points exactly, Jason. It's becomes this notion of, what is my access to data on the back end from an application provider standpoint, and the initiatives that have been around, right? If I own these infrastructure services and I have different groups of application developers that want to leverage that data, if I have an open approach, I'm going to want to get that information out. I'm going to provide API services, whether that's to internal application providers, whether that's by regulation, and I need to push that data out through open APIs. I'm typically doing that with some type of API gateway service, right? Providing both access and perhaps even some, what you see listed as composite services, right? Maybe I'm actually taking data in the back end, doing some transformation. Maybe I have to, change the format of that data, normalize, whatever that process is to converting the back-end information to a usable format in the API interface. It really comes down to, it's more than just how do I expose the data to a request-based mechanism. It's like, oh boy, now I actually have some management work to do. And typically there's not a whole lot of monitoring going on when it comes to the spaghetti you see here in this architecture, right? It becomes very hard to scale, and you basically are solving these problems one by one. Every application developer wants access to one or more of your applications or one of your systems of record. They may or may not, and probably don't have any idea what that looks like, how to access it. Perhaps it's new technology that they don't yet have the skills for. Perhaps it's very old technology that they don't have the skills for. And so every time you develop one of these front-end projects, or one of the applications, it becomes a project, right? You have multiple teams and so forth. So very, very slow process of developing. You can try to be proactive and say, okay, I want to expose such and such an API. But if you're a very dynamic business, if you're bringing on new business, business units, if you're doing acquisitions and so forth, this architecture is always changing on the back end. And so really some of the downsides here of the traditional approach here is, one, it's very tightly coupled. And you'll hear me say that over and over. It's very tightly coupled between the application and the data you're accessing. Both actually tightly coupled to the end system of record, but all through every layer of this architecture. Typically in a do-it-yourself type of platform, there's not the foresight. People are sort of reacting. They're building this up one by one. There's that lack of the holistic management of the whole platform and solution. It's hard to develop, and as I mentioned, niche skill sets, right? So really, it's something that I think has seen its time in some of the solutions here, and we need to flip that paradigm. And it really becomes one of, how can we decouple? How can we get to a scenario where we're more event-driven than request-driven, and more importantly, from the business aspect, how can we accelerate the digital transformation? How can we accelerate servicing these applications or developing new applications and getting them out to the people that matter?
So let's go back to that slide. Sorry,
Sure.
I had comments to that one.
My bad.
No, but back to that. Yeah, there we are, traditional. So it says on the top, traditional IT architecture, and that word traditional, I mean, it's a bit of a moving target, right? Because this is still a modern architecture approach. It says on the left, hybrid integration platform, a Gartner term. And what Gartner is referring to there, in part, is the combination of both on-premises and cloud technologies. So this could very well be iPaaS as well as on-premises technology or some combination, but it's also a reflection that the systems of record are heterogeneous, right? So they could be different kinds of systems of record. They could be on premises or in the cloud as well. Now, Andrew, you mentioned how this is tightly coupled, and in many ways it is, although this notion of tight coupling versus loose coupling, I mean, this has been one of the challenges of middleware-based architectures since the SOA days, right, 15 years ago.
Yeah.
And the loose coupling was intended to appear at the API gateway level. The idea being that the API gateway will expose abstracted APIs that now consumers, which are those circles at the top, can interact with in a way that provides a measure of loose coupling. That is, if there's if there's a change in the underlying functionality, the API is abstracting that, and the consuming requests don't break. And we'd be able to achieve some measure of loose coupling, but it never lived up to its hype, right? We talked about how loose coupling was what SOA and web services were supposed to deliver, and it did in some situations. But Andrew, you're right. There was still a whole lot of tight coupling going around, and that's one of the challenges with the traditional IT architecture, the hybrid integration platform we see here. Okay, so I know you want to go to the next slide, so let's do it.
Well, it's keeping us honest, right?
Okay, so the notion of a digital integration hub. So yet another Gartner term, and if they'd asked me, I would have called it something else, because this word digital, as I mentioned at the top of the hour, it's a bit overhyped. And what makes this digital versus not? Are they saying that, oh, all of a sudden we're using zeros and ones? Not really. I mean, it's real. I would have called it a real-time integration hub if they'd asked me what to call it. But we're stuck with DIH, digital integration hub, and we're really rethinking that traditional model, that HIP, the hybrid integration platform that we saw on the previous slide, along real-time lines. So we're saying, instead of making request reply the fundamental pattern, obviously it still supports request reply, but we're making real-time behavior the fundamental pattern. Now, what do we need to do in terms of all of this middleware to make that work? And that's really the key challenge here. So let me turn it back to you, Andrew. How are you to folks defining digital integration hub?
I think it comes back to solving the problems we were just talking about, right? And a digital integration hub, to me, is that middleware platform that flips that paradigm to become a more responsive experience for the application users. And that's achieved by having 24/7 access to the platform, having 24/7 access to the data that ultimately the source of truth or system of record is maybe not available 24/7, yet you have to have the DIH to provide that always on access. Decoupling, right? Basically, as we move towards that model and the ability to sort of accelerate to the cloud and to different technologies, you're absolutely right, Jason. It should be abstracted from the consumers of your APIs. And so as you transition, either from a business standpoint, changing technologies or bringing on new business units or mergers or separations or whatever that is, the consumers of those services should not realize any difference. It should be consistent interface. And then more and more as we look at what DIH is, it's really about hyper acceleration, low latency, and performance, right? So it's not just about opening data and aggregating data and maybe transforming it, but really making it high performance. Because as we look at this digital journey, right? It's not just about saying, hey, can we improve on something we've done? It's like, can we add more and more? Can we actually expand upon the value and develop more and more applications and APIs on top of our data? And so acceleration is key. to this process. I will mention one thing though. It doesn't mean everything you have should be sort of digitized and pushed into the into the middleware, right? This is really about the focus on strategic and highly available, useful data. Let me put it that way.
So let's move to the next slide because we have this compare and contrast between the two diagrams. So if you sort of squint at this diagram, it looks a lot like the previous one, right? The traditional architecture. But then if you look more closely, you'll see that there are some fundamental differences, and the real fundamental differences between the DIH architecture and the HIP, or the traditional architecture, are at that data management layer and the event-based integration layer. Right at the top, we have the API gateway, although now we're adding event gateway to it, so that's an important point as well. But we're supporting that with high-performance data store, the multi-model approach to dealing with data, as well as the event-based integration layer that now interacts with systems of record of various sorts that may be traditional systems of record that are expecting request reply. That could be, a database, a SQL database that we're expecting SQL queries, but not necessarily. Right now, we have this event-based communication protocols and formats, that lower blue layer there, that is perfectly willing and able to interact with real-time data streams of various sorts, and it could be various different kinds. So as Andrew mentioned, we're not expecting all the data to be real-time. It's not about all streaming. It's really about supporting all of the different data protocols and modalities that an organization is expecting to have, including the real-time ones. So if you think about the behavior at the user interface now, you think about the sorts of apps that you might want to use. You may want to have a request reply, right? You want your bank balance, but you may also want to have some sort of real-time reporting. You may also want to have some sort of integrated video or audio or virtual reality content as well, as part of that story, or augmented reality, whatever the application has to be. And there's going to be a mix of those things, right? You're not going to have all of one necessarily. You're going to have a mix of different technologies or experiences that you require, which now require a mix of different technologies. So all of this is part of the story. And one of the key parts of the story is that API layer, that now it's APIs and event gateway. And traditional APIs, traditional RESTful APIs, they weren't really designed for events, right? RESTful APIs are based on the HTTP protocol and doesn't require HTTP, and HTTP actually has, some real-time components to it now, modern HTTP, but it's still sort of based on this traditional, get and post kind of mentality. But event gateways are beyond that, right? It's not just get and post anymore, right? There's more different ways of interacting. And so requires a rethink now at that API event layer, where now we have different kinds of applications interacting with the digital integration hub in traditional as well as modern ways, in a combination. And that would be very difficult to support unless you have the appropriate technology. So turn it back over to you, Andrew. What are you seeing as the specific benefits gained by taking this DIH approach?
Yeah, I'll actually start by kind of going reverse of what you just said, on the sense of in order. From an API gateway standpoint, event gateway, it's really beyond just offering a RESTful service, as you say, right? Multi-protocol, more control, and the ability to react upon events, whether those events are coming from the application, or just as importantly, that those events coming from the systems of record and proactively being pushed in, right? So a key part here is that event-driven concept of data, transactions, services, streaming, information. And as it relates to the back end, right? We talk about things like change data capture, message queues, highly performant data streaming models that can actually get that data in a more low latency format to get it available for consumption. And looking at and breaking down the stack a bit more, right? As we look at data services and the high performance data store that you see in the middle of the stack, more and more, this is meaning in memory, and this is meaning more than that, like an in-memory data grid. Because as we look at, if we were to build this piece by piece, you'd gain some performance in different areas, but a holistic approach of an in-memory data grid for the high performance store gives you that ability to actually have co-location of these features, meaning you can have your data highly responsive running in memory. You can actually have the event streaming in a proactive way so that the transformation of that data is pulling all those disparate data sources into a uniform data model. So consumption, you can abstract where that data came from to the application providers. If I want to use SQL, I can actually access the data in SQL. If I want to use REST and build an API service that exposes that, who cares where the data came from as long as it's consistently available in high performance. If I want to use a Java API, .NET API, and so forth. But the importance back to the in-memory data grid here is that I can actually co-locate the execution of those services. So the reaction to those events, as new data comes in or application requests come in, co-location is basically literally within the same memory stack, running the actual microservice or data manipulation or services on the data that's literally a byte over in memory, right? So it's really talking about going beyond just saying, hey, I want to get the best relational database as my core. Whatever that data technology is to actually, I want the most hyper accelerated possible combination of services and data in that data management layer. And I'd be remiss not to say that you can't just have it be performance based, right? Now you're talking about mission critical, you're talking about resiliency, high availability, and the ability to actually span, not just sort of some monolithic infrastructure on-prem, but actually disparate locations, right? You want cloud, accelerating the journey to the cloud, and how do you actually build a DIH architecture that can replicate, these highly sensitive systems of record, but replicate them in a controlled way out to various cloud resources for API consumption there. So DIH to me is a lot of things, but to me, if I summarize it, it's high performance, always on architecture to accelerate digital transformation, to accelerate application deployment.
So what sort of adoption is this approach getting? I mean, is this still theoretical, or is this being adopted in enterprises? And if you have any real world stories, that would be great.
Yeah, absolutely. And I think, definitely have some stories. The adoption is actually current and active, right? So DIH concept came out a couple of years ago. I think a lot of people at a glance first said, I guess back to your point, Jason, right? You look at the two architectures like, oh, those are very similar, right? A lot of people said, oh, I'm doing this, I had this idea first, right? But in reality, they're doing pieces of it. And so what we're seeing now is a couple of different things. So you have like the greenfield, where somebody's like trying to design from ground level up the most high performance solution. And they'll take this as the gospel. They'll really go through and say, I need these components to my DIH. Looking for out of box as much as possible. And I want that holistic management to that. So adoption from that standpoint, absolutely. But that's a smaller percent, right? A lot of folks already have infrastructure in place and they're looking to convert. And so they're really focused on how to, not so much, the value. They buy in. There's value in high performance data store. There's value in this architecture. How do we actually get the fruition of getting all these disparate data systems? How do I actually get them to event stream into the DIH? And so that's really the reaction we're getting, is that they know the problems, and they're literally, I can tell you many times where organizations will come to us and discuss with me, like, I need these things. I need to get away from all these niche skill sets. I need to, and I hear this term, I need to open my data. I need to get it off of my plate into the application developers' hands. I will tell you some of the acceleration, stories around really taking the monolithic architecture out. So we have again, I don't want to go too much in sales pitch here, right? But we have a bank that leverages the DIH concept in our DIH product to offload from mainframe, so DB2, vSAM, out-of-bus data into the DIH to actually serve up in a DIH in the cloud open APIs. So by regulation, they have to open some of these API channels. They need it to, one, not be an overwhelming burden on their existing infrastructure. So offloading to the DIH provides that ability to scale as that API usage grows. And then two, they want to do it in a controlled way, right? They want to do it in a way that gets the data into the DIH, has high-speed replication and high performance. Because at the end of the day, whether it's another business unit of your own or some other B2B using your data, it still reflects on you as an organization of how performant access to your information is. And so that's one example. Other examples, airline industry leveraging, our technology, especially these days, right? You have all the different cancellations going with COVID. In fact, I just took a trip recently and my flight got canceled 3 times in a row. These are challenges that are more than just like, how do I actually, do I have a plane and is there maintenance, right? This becomes like, who's sick? How do I actually reconcile the entire population of my pilots and my crews and what equipment's where and what flights need to be scheduled, right? So all this information, as I mentioned, milliseconds matter, right? All this information being aggregated in high performance allows you to react to those type of situations. So really we see, this continuation of folks looking for, especially again, back to the world of COVID, right? Things are rapidly changing. And what everybody assumed was, hey, we have to do this push towards the digital journey is now like, no, we done it now, right? Not now, yesterday, right? And so that's kind of the flow we're going through right now.
So if I put on my, devil's advocate hat and look at this slide, I'm thinking, this looks like just another middleware layer cake stack, and it looks a lot like the digital integration hub, and I already have a middleware integration stack in place. So I guess the 2 key questions then is, how do I know if I need a DIH, a digital integration hub? And the second is, are you telling me I have to replace my existing middleware stack with this, or is this some sort of add-on? So I want to run this as well as whatever I already have.
Great question. Great question. So there's 2 things. As I mentioned, it's not just a caching solution, and in some cases, you just need a caching solution, right? So if you have a single application that you're trying to accelerate and you have a single use case, I'll happily say we have technologies to suit that as well. But when you do you need a DIH architecture? It's when you have multiple systems of record, if you have disparate data sources, if you're looking for consolidation of that data in high performance and always on, as I mentioned, some of the benefits. Does this mean that you either go with the DIH and you have nothing else? No. In some cases, you can have a hybrid approach, serving the APIs that need to be high performant through the DIH. Other API stacks can stand in place, right? And answer those requests. I mean, are we going to replace the processing on third-party APIs? No, like right there are third-party APIs that you're probably consuming in your own API stack. And so it really comes down to delivering on those business needs, right? What are you trying to achieve? What do your users need? And what can you achieve by offering more high-performance services and more services at that? And then finally, the main point here is if you're suffering from the plight of these never-ending projects to deliver an API or service, meaning it's taking months and months, right, to deliver these things, and you want to get down to days and weeks to flip these things, or if you have changes and you need it to take hours, not to have to plan out for months to flip a change on an API, that's when you need a DIH.
Very good. Well, we're at about the 3/4 mark, so let's go ahead and open it to Q&A. So as a reminder to our audience, just simply click the Q&A button and feel free to type in your question, and we will, if we have time, we'll get to as many questions as we can. So the first question, and I know you answered this one, so I'm going to sort of ask it, sort of go a bit in depth. And so the question is, isn't this just a cache? And you obviously said no, but so I'm going to twist it around a bit and say, can you be a little clear as to why this is different from a cache? Because there aren't a lot of commonalities, and it does do caching, right? So can you sort of be specific as to why this is not just a cache solution?
Well, it's not just a cache, in the sense that you can think of it as more of an event-driven. Well, let me start by saying the DIH, the memory in memory aspect of it is one component of it, and on its own, that's a cache, right? Like
Okay.
but the question about a DIH is how do you proactively or in an event-driven way get the data into the cache? Because it's not just simply moving the data from A to B. There's likely some data validation, there's data aggregation, there's ETL of the data. And so if you wait until request time to actually go and make that request, hopefully that system of record is available. Hopefully it's low latency. And then two, hopefully the processing that you're executing on that data, the ETL process or whatever validation and cleansing you're doing, is high performance enough to keep up with your API SLAs. And so the difference here is that all those processes that happen on the request base are now transformed into an event happens somewhere else on the data, some other access point on the system of record. That event is immediately processed through the DIH, and the current state is already transformed and available. So when the API call comes at the top of the stack, it's immediately responded to. You don't have to go through that sort of reactive transformation of the data. It's already available.
Okay, well, another question we have, a similar type of question. How is this different from an operational data store? I must say it does sound pretty similar to an ODS. So what are the differences there?
Well, I mean, from an ODS standpoint, and again, there's a variety of flavors, right? But from an ODS standpoint, you're really talking about getting operational information, operational reporting, pulling the data that you need in order to access that. And typically, you're looking at things like SQL access to survey the data, maybe generate reports. Maybe you have different views and dashboards and so forth. From the DIH standpoint, it's not about, in some aspects, yes, you actually want to actually do some analytics and get some reporting off of the data on the stack. But it's more about servicing the APIs, servicing the applications. And so beyond that, it's multi-protocol, it's highly accelerated transformation and event streaming into this, right? It's not stale data, it's up to the moment, and multi-API protocol available.
Yeah, very good. Okay, another question came in terms of time savings, can you provide a ballpark estimation of how much quicker apps can be launched with a DIH as opposed to traditional IT infrastructure? So what is the speed benefit in terms of comparing it to traditional?
Yeah, I mean, again, depending upon your organization and the level of digitization you're in, and if you've already adopted APIs and so forth, we're definitely talking moving from weeks to days, right? Months to weeks, depending upon, it's a level of 5x, 10x, maybe 20x, right? Depending upon what state of the digital journey you're in. From our aspect, it's more about the ability to, I guess if I look at, I guess I'm wearing my GigaSpaces sales hat now, right? Just to be completely transparent. It's about, what out of box can you get with the solution? Like, can you simply get the in-memory, or can you get the in-memory with the ability to provide a holistic solution that has monitoring and metadata and the ability to actually, facilitate the rollout, and not just the rollout of the APIs, right? But the CI/CD, like you need to make changes. You're constantly in this development cycle. It's beyond just delivering a connection to a backend data source and throwing it in memory. It's that holistic solution. From our standpoint, we're seeing large organizations, with lots of data. In some cases, we have a digital bank has all their data in the solution, right? Large organizations doing constant development and able to develop new APIs, push them out in a matter of hours and days.
Very good. Okay, well, let's see, another question came in here. We have somebody is asking, I've met banking clients who state they have already built a DIH. Do you believe in-house solutions exist within this concept? Or what is your opinion of an in-house DIH? Let's put it that way.
Okay, and so of course, I've worked many years in banking, and I've seen the span of technology skills in various banks. I won't name any, good or bad. But with that said, the concept exists, right? The concept, if you have a massive development staff and you can actually take the challenge on and pull all these different technologies together and manage them and provide an umbrella monitoring and assurance and so forth. So do components of this exist? I would say absolutely. Does a holistic solution that gives you sort of the 24/7 SLAs and you can sleep at night type solution exist? I think that's a bit of a challenge to do. We have an entire development team dedicated to just this DIH concept, not having to run the business, not having to actually deal with all the other headaches that certainly exist in any business. And so we're really talking about, hey, if you want all those headaches gone and you want a out of the box solution, that's where we come in.
It definitely makes sense. Okay, so one more question. This may be our last thing. Is we're running low on time. What do you mean by loose coupling, and how is the DIH more loosely coupled than the traditional one? So I'll take the first part of this one. So when we say loose coupling, what we're really talking about is we have an interface, an API or some of the interface, and we want to be able to make changes to the underlying system, the system of record, without breaking the consumers. So there's a consumer application is making a request, say, of some sort of API, and if we change something under the covers, it might be a change in data format, might be adding fields, it might be reworking the API in some other way. We don't want that to break the consumer, right? So the consuming application, we don't have to go in and fix that. So a tightly coupled interaction, if you make a change in one place, you have to change the other part of the interaction accordingly. But with loose coupling, ideally, we don't have to do that. So the reason it's loose coupling versus no coupling is the idea of a contracted interface. And this was a big part of the web services story. They had formal XML-based contracts that described the interface. And as long as both parties, consumer and provider, agreed to the contract, that in theory, you could make changes as long as they didn't break the contract. Well, in the RESTful world, the contract is more implied. We're basically saying we're going to follow REST principles. We know how guest, get, and post work, and we know how the various fields work, and we're going to use the media types, standard media types that describe the format of our data. And as long as we agree to those, then we're going to have interactions. So then the question is, well, for an event gateway, how are we getting more loose coupling than we would with a traditional RESTful interface? And I think I'll lob that one back over to Andrew. So what really makes this more loosely coupled than, say, a traditional ESB, for example?
Yeah, great question. So I agree with everything you said, by the way, up to the point of where we get into the actual DIH architecture. It means decoupling the reliance upon a specific data model as well. And so from the DIH standpoint, when we pull in disparate data sources, and I'm talking, it could be legacy, it could be new technologies, you could be combining relational data with document type data, JSON streaming, data artifacts, like all this different disparate data. In the DIH concept, it becomes its own data model. So a uniform data model across that. So the contract is to the API, I will follow this data model specification, not just the API calls, but actually across the actual backend stuff. So as backend systems of record. So when those new systems of record come in, or you transition, that transformation into the DIH high performance data store occurs. So you're actually technology agnostic on the back end. Meaning, as long as I serve up that contract, as you mentioned, loosely coupled to the API consumers, I'm now actually pulling that data, and I'm actually adding sort of two levels of decoupling. One to my API, offering it to them, but also on the back end, I can actually pull in any type of data and transform it into the uniform model.
Yeah, that's a great answer, and I think I'm glad we got to that, because that flexibility in terms of the data model is something that we just did not see 15 years ago when the whole SOA wave. That was, we were stuck with whatever data models the underlying systems had, and we just had to deal with that. So we have just a couple minutes left. There's one question came in, and let's see if we can squeeze this in. How does the DIH apply to mainframe environments to help with new digital initiatives? Andrew, you want to take that one?
Yeah, and I think it's actually a good question, because it actually harps on some of the topics we're talking about, right? I don't want to go down the path to say this is only a mainframe solution. Let's just be clear, right? We're talking about aggregating modern technologies. We're talking about cloud deployment and so forth. But their mainframe's not going anywhere. In fact, I have one organization I'm speaking with that says, you know, and I have one use case where I want to get rid of the mainframe, but that mainframe transition is going to be 15 years. And then we have another use case where we actually don't want to get rid of the mainframe at all. We love the mainframe. We just want to actually offer services and other services and open that data out to other use cases. And so from the mainframe standpoint, we gain all those benefits. We don't have to rely upon first, always on, always available, and any type of latency in that data transition. Also cost offsets, right? And this is not just goes to mainframe, right? There's the cost of MIPS. You know, anytime you do anything on the mainframe, you're gonna accumulate some cost to the provider. But this could be data egress from a cloud service, you know, whatever application or services you're consuming on the back end, you want to limit the amount of times you need to do that. So by pulling the data into the DIH, you know, it goes back to the same concept, right? As caching, Jason, right? You know, you're not asking for the same thing over and over. Well, even worse, you're not accumulating the same cost for the same thing over and over, as it relates to asking the mainframe for more MIPS to do the same thing. But really, it's part of the DIH story, which is, you know, modernization and offloading from monolithic legacy infrastructure. Yeah, that's only part of it, though, for sure.
Well, it's about time to wrap up. So, Andrew, do you have any final comments?
Yeah, I basically just you know, threw together, you know, a few main points here, and it's really about, you know, not repeating your crimes of the past, I would say, right? Making sure that you have that approach of, you know, don't repeat yourself. Like, if I have something that I'm constantly accessing, maybe it's time for that data to be pulled into the DIH. If I have something that needs high availability, that needs to have always on, that needs high performance, maybe it's time for a DIH. That concept of decoupling, Jason, whether it's loosely coupling or complete decoupling, or the decoupling I described, certainly we would recommend that. It would help you grow. It helps your transition to new technologies. It helps your transition to the cloud. We didn't really touch too much on scaling in this conversation, Jason, but really having that capability of decoupling and pulling into this DIH architecture, that high performance data store would also give you the ability to actually expand vertically, horizontally, you know, both for, you know, peak loads. Maybe you anticipate them, maybe you don't, right? But you need that ability to adjust. And then absolutely, when you look at DIH, you know, we had that question on, you know, could somebody build this themselves? Really a holistic solution that actually includes management, includes governance, includes the ability to actually monitor the performance and those needs for scalability. You know, certainly that scalability being implemented, you know, through high performance data stores is really we get down to. So I really would just summarize by saying, you know, all the points we brought up, both as challenges and certainly what DIH brings. If this resonates with you, then it's probably time for you to think about a DIH.
Very good. Well, thank you very much, Andrew. We should wrap up here. So you can reach GigaSpaces at gigaspaces.com, very simple, and join their next webinar that's coming up, Solving the Digital Innovation Challenge with DIH. Massimo Pezzini, formerly of Gartner, who coined the term DIH, is going to be presenting, and you can ask him why he didn't call it real time and called it digital. So register on the GigaSpaces LinkedIn page for that. And thank you very much. This is Jason Bloomberg from Intellix. Have a good day.
Thanks, Jason. Have a great day, everyone.